Intro to functions. We're going to start with a little review on relations. Relation between two variables x and y is a set of ordered pairs. Um, X or y both can be categorical or numerical, or one of them can be numerical and other one can be categorical. An ordered pair consists of an x coordinate and a y coordinate. A relation may be viewed as an ordered pairs, or a mapping design, or a table, or an equation, or a graph, or written in the sentence form. X values are called the inputs, are independent variable, or domain, and y values are called output, dependent variable, or the range. Example 1, what makes this a relation? Well, we see elements are the ordered pairs, so this is a relation, and our domain will be all the x values. All the x values are going to make up for the domain, and the range will be all the y values. Collection or set of all the y values will be the range. -5, -4, -3, -2, -1, and 0. That's my range, and domain is 0, 1, 2, 3, 4, 5. Collection of x values is domain, collection of y values is the range. What is a function? Function is a special relation in which every input has exactly one output. That means one input cannot be connected to more than one output. Here's an example. We want to see if this is a function or not. All we need to do is we only need to focus on the input values, the x values. The y values don't have a whole lot to do with deciding if a relation is a function or not. So all the x values, 0, 1, 2, 3, 4, 5, are unique and different, and they're not repeating. So first of all, is this a relation? Yes, it is a relation because we have the ordered pairs. Second question, is this a function? Because my input values are not repeating, so each unique x value I have, yes, it is a function. Because each input value is unique and different, we don't have one input value connected to two different outputs, so yes, it's a function. Another example, is this a function? Let's first take a look at all the x values. There is trouble. Repeating x values, input values are repeating. So no, it is not a function. Is it still a relation? Yes, relation is just a collection of ordered pairs, which it is. So this is a relation, but not a function. Another example, which relation mapping represents a function out of these two? So choice 1 or choice 2? In choice 1, I see all my inputs are unique and different. So this is yes, a function. Choice 1 is yes, a function. And let's look at choice B now. We do have one input connected to two different outputs. That is not a function. Both are relations, but the second one is not a function. Second one is a relation only. The first one is a relation and a function both. Function is a special type of relation, okay? Which relation mapping represents a function? The first one is in trouble because the elements in the first one is 2a, 2b, and 2c. And that's not okay because my input values are repeating. So this is not a function. And the second one, my elements are a2, b2, c2, which is okay. So second one is yes, a function. First one is not a function. Output values can repeat, but the input values cannot repeat. Graph of a function can be tested using vertical line test. So a relation is a function if a vertical line drawn through its graph passes through only one point. Vertical line should not touch the graph at more than one point. We also call it the pencil test. So if you move a pencil from left to right on your graph, your pencil should not touch the graph at more than one point. Here's an example. So if you move this pencil along, your pencil will not be touching the graph at more than one point. So yes, this will be graph of a function. Another example, if I move my pencil along, my pencil here will be touching the graph at two different points, and that would be not a function. This graph is not a function. It's a relation, but not a function. Now we're going to do the vertical line test to decide if each of these is graph of a function or not. Number one, yes. Number one would be yes, a function. Number two, we can do the vertical line test. Yes, a function. 3 also we can do a vertical line test, and at any time my pencil is not going to be touching a vertical line, will not be touching the graph at more than 1 point. And number 4 is going to actually fail because my pencil is touching the graph at 2 different points. 5 is also not a function. 6 will be yes a function, and 7 will also be yes a function. 8 will be not a function because my pencil is touching the graph at more than 1 point, or vertical line is touching the graph at more than 1 point. And the very last one, number 9, will be yes a function again, because my pencil is, or vertical line is not touching the graph at more than 1 point at a specific time. We're not talking about axes, x-axis, y-axis. We're talking about the actual graph that's given. How do we identify domain and range from a function's graph? Domain is going to be set of all input values or x values found on the x-axis. Range is a set of all the output values found on the y-axis. Is the following function discrete or continuous? What is the domain? What is the range? Well, if you look at the graph, the function is not continuous because it's given as a bunch of dots. So that's one thing we are noticing here. The dots are not connected, so the graph is discrete. And the domain will be all the x values. So just noting down the x values from x-axis and making a set out of those. That is my domain: -7, -5, -3, -1, 1, 3, 5, and 7. And the range here will be all the output values or the y values found on the y-axis for corresponding points on this graph. Another example, this graph we can see is continuous, and the range and domain will be written in the interval notation because we don't have discrete points. We do have continuous graph here. So for domain, every single value between -8 and +8 for x is a part of my graph. That is going to correspond to some point on my graph. So domain is written in the interval notation. Keep in mind, we will be using interval notation. This means starting at -8 all the way to +8, all x values are a part of my, all x values are allowed in my graph, or they're part of my graph. And range is going to be the y values. So for range, be careful and look carefully. The y values only go from -6 to +6, including -6 and +6. So if we had a hole at one of those points, we would use the open parentheses for one of the endpoints, but it looks like there's no hole on this graph. And if we did have arrows going in both directions, then that would make it continuous, and that would mean if I had an arrows here, then the domain would change. Domain would become -infinity to +infinity, and the range, the highest value of the graph still looks like is a +6, and the lowest value will be -infinity. So range would become -infinity to +6 in that case if we had arrows. But if we don't have arrows, then if there's no arrows, then domain and range would be, domain would be -8 to 8 with brackets, and range would be -6 to 6 with brackets. Evaluating functions in the graphical form. So here we're given a graph of a function, and we want to evaluate some values based on the graph of the function. We want to evaluate this function for some values. F of 1 equals what? So I'm looking for, remember, f of x and y is the same thing. They can replace each other. So I'm looking for, when x is 1, what is y value? Because this is f of x. So when x is 1, what is y equal to? Y is 0. That means 1, 0 is a point on the graph. What is the function value when x equals -2? In this case, we are given the x value and we're looking for the y value. So when x is -2, which is here, what is the y value? That is going to be 6. So f of -2 is equal to 6. When x is -2, y is 6. And we could be asked, I'm just going to add another part to it, f of x is equal to, let's just say, f of x is equal to 2. So this one, we could be asked solve for x, or we are trying to figure out the x value. What is the x value when y is equal to 2? And in this case, we would say x is equal to -1. For x equals -1, the y is 2. Right, function as an equation. Functions are usually given in terms of equations instead of ordered pairs. Example, y equals -2x minus 3, y equals square root of 2x, y equals 1/2 x squared plus 5. All these are written in the equation form. We could express them in the function form as well using the function notation. F of x equals 2x minus 3 would be equivalent for the function form for this equation, y equals 2x minus 3. X is known as independent variable, y is a dependent variable. X can be anything it wants to be, and the value of y will depend on it. How do we determine if a given equation represents a function? Steps will be solve the equation for y in terms of x. If one or more y's are found, actually two or more y's are found, then that's a problem. That means it would be not a function, because that means one x value will be connected to more than one y, which is going to fail the definition of function. So here's an example. If I go ahead and solve for y, and my equation is x squared plus y equals 4, y can be written as -x squared plus 4. I did not end up with two different y's, so I would say yes, it is a function, because each individual unique input will give me only one unique output. And I will not have repeating input values here. One input value will not give me two different outputs. Another example, how do we determine if an equation represents a function? X squared plus y squared equals 4. Let's go ahead and again solve for y. Y squared equals -x squared plus 4. If you like, you can write it as 4 minus x squared. Same thing. Addition is commutative, so it doesn't matter in which order you write these two terms. And when we get the y by itself, we would take square root on both sides, and we actually found two different y values. We found two different y values, square root of 4 minus x squared and negative square root of 4 minus x squared. And that's a trouble. That means this is not a function. In this case, I'm going to have one input value related to two different output values. So that would be not a function anymore. Because if x is 0, then y can equal plus minus square root of 4, which means 2, or y can also equal -2. So one input value is related to two different outputs, and that fails the definition of function. This is going to be not a function. Go ahead and practice these two and pause for a minute and check if for the first one, if these are functions or not, or y as a function of x or not. So first one, when we solve for y, it would be -2x plus 6. This is going to be yes, a function. Next one, it would be square root of plus minus 1 minus x squared, and that's going to be not a function. Next, we'll talk about evaluating function. So for evaluating function, we could be given f of x equals 2x plus 3. We could be asked to evaluate the function at f of, or find f of -1. Given we are given the equation form, we could be asked to find f of 0, or we could be finding x when f of x is equal to 5. So I'm going to create this problem right now and go through it. For first one, we're looking for f of -1. So I'm given the x value here, and I'm trying to find the y value when x is -1. So that means f of -1 would be 2 times -1 plus 3. Replace the x by -1. -2 plus 3 is 1. Next one, f of 0. So f of 0 will be, replace the x by 0. 2 times 0 is 0. So f of 0 will be 3. That means when x is 0, y will be equal to 3 for this given function. Next one, we're looking for x, because we're given f of x value, we're given the y value. So we're going to replace this 5 by the y. 2x plus 3 equals 5. Subtract 3 from both sides. 2 equals 2x. X equals 1. So that means x is 1 when y is 5. So if you want to write the ordered pairs from it, x is 1, y is 5, a point on the graph, x0, y3 is a point on the graph, and x negative 1, y1 is also another point on this graph. That's all for this video.